Welcome back. We'll try another example from section 2.1, the separable method. In this case, we'll look at exercise number 13. We're going to solve x prime equals t plus tx squared. So, first off, we check that it's in the slope form. And then we see if we can factor that slope form into a function of t times a function of x. If we factor that t out, we get 1 plus x squared left. Sure enough, that's separable. So now we separate and integrate, now that we know we can do it. So, we end up with 1 over x squared times dx. On the right, we have t times dt. We integrate both sides. Now, this is a quadratic, but unlike the previous an example where we can factor that quadratic, in that case, we would have used partial fraction decomposition. When we can't factor it with real values, we look for other options. In this case, we actually have, going back a little ways, one of the trig integrals. This is the integral of the tangent inverse function. So, good review, huh? We end up with the tangent inverse of x equal to t squared over 2. I'm going to send my constant for my first integral over here. So we get C1 is a combination of the two constants. That's an easy way to do it. Now, to solve for x, what do? Well, we want to get it out of the tangent inverse function. So what function do we use to get rid of or invert the inverse tangent function? Well, that's obviously the tangent function. Notice that the tangent function is of the full sum here. So that leaves us with x equals the tangent of t squared over 2 plus c1. And since we've been able to solve for x all the way, we can even drop that 1 and just say it's plus c. That is our arbitrary constant.